So basically, we start with the abstraction phase. As said previously, we used carefully designed TUIs to mimic real-world scenarios. In this case, we'll try to teach object-oriented concepts, abstractions, and inheritance by focusing on a real-world scenario, which is building a class of a truck and a class of a car, and then extracting all the common features that can be found in each of them. So by placing TUI on the car, the first class comes up, and as you can notice, everything is grayed out, but these are lit so that to advise the user that these can be used in conjunction with the car to actually build a model. Same thing goes for the truck, which when placed here, its class comes here, and these are lit up by the Arduino actually to indicate to the user that these can be used in conjunction with this site to build this class, so with this site to build this class. When starting to place components, like for example this color, which can be placed near this truck, this will come up the same way, indicating that this is part of this class. So it indicates here the color lights up green. If we add up more components to it, like wheels, put it in its proximate image, and so it lights up. We can do so also with the car class. If we place like speed, it lights up and switches off from here. As soon as I have something in common, which let's say we can put in the color, the Arduino turns the servo, so that indicates that, listen, we have a common feature, and between the both classes we can make an abstract class if we want to, but in reality how much sense would it make to make one class with only one property in common? And so is the reason for the distorted car. As soon as we add more properties which are in common for both classes, the image will get less distorted. As you can see, if we add the engine for one side, always put it approximately, so we put the same for the car, and the car gets less distorted, indicating that, listen, we now have two common features. It would make more sense to do an abstract class so that we can later inherit from it. This is a method for the truck. It's only found at the truck, so it wouldn't be common for both, so it can be extracted, and so is the acceleration. If we put the last fiducial, we can see that now we have a clear image of an abstract car, which we can pass now to extract the common features. So if we remove the abstract class here, we put it on the abstract version of the class, we should have a small animation indicating that, listen, we are extracting all the common features. For this process, the TUI has been disconnected, so that there would be no actual change while the animation was going on. We can then now place the abstract car to the inheritance phase so that we can move forward. Now that we actually made an abstract class, we can make use of it. These are some limitations that we incurred, between lights and fiduciary reading, and there's stuff that we really didn't. couldn't do much about it. So now we can pass to the inheritance phase. We have all these duplicates, but we can remove these. Indicating that, listen, now that we have one mother class and we're inheriting from it, super class, if you will, we don't need these anymore, so these are all lit off, and these are all lit on, indicating these now have a separate meaning to them. And now that we have an abstract class and we're inheriting from it, we can also adjust its properties and also adapt to them. We don't need this car anymore, which was the concrete class, the two concrete class that we extracted from them. So the abstract class we're inheriting from it, and we also can change or modify the color or properties, and even add methods to them. So like this, we are changing the color to blue, and if we could replace this the settings fiducial, we can also add the methods and or properties accordingly. So if we the light, you can see, and leave it for a couple of seconds. The reason being is so that there wouldn't be any variation when passing from one method or property to another. So the light has come up in conjunction with the car, so its property can also pass to add the speed method, and the speed method comes up. Also the direction method. And finally, you can add also a spoiler. So having added all these properties, we can put the fiducial back. We can also modify the engine. We can get bigger or smaller. And we can also manipulate the acceleration, which is this method here, passing different properties, which we couldn't have done previously when first inheriting from the abstract car, because it didn't have those methods, so we couldn't actually modify them. Now that we have added more methods to the abstract version that we extracted from both classes, well, now we can also modify it. So we can increase the speed, and so it reflects both in the car, showing more speed, sort of, and also the parameter that it has been passed to the speed method. And we can increase the wheel size as well, indicating that when inheriting from a class, from an abstract class or previously made class, we can also adjust its properties, its current properties, adding onto them and modifying as we see fit. This is a part of instantiating the car, so this class would be instantiated like this, would ideally result in this class, which is which symbolizes this class, and getting an object out of it. Of course, we can get more classes, more objects by doing the new keywords and instantiating a lot of them any way we like. We have here also past parameters. This is the constructor. If we didn't get all these features, like for example, say we extracted only the color from both the previous concrete classes. It would only show the color, and the wheel and the engine wouldn't show up. So the wheel and the engine would be deducted from the constructor and the class variables. Okay? I think that's